been doing this with my special class, but for methods, for some lessons, talking pretty fast and you need revision. I know that like in one of some also, you might forget that, that's why I'm recording it. Okay, because I don't want to, we don't actually have more time in turn 2, turn 3 to go back to this concept. Okay, so this is the only lesson we're going to talk about composite function. All right, so composite function in year 11 we learned a little bit. Basically, it looks like this, but don't worry, in the exam, you won't see notation like this. Most likely, you will see, because we know G with F, basically we just write G Fx, okay? So in the exam, you most likely will see notation like this rather than this. So don't worry about that. Okay, so altogether for composite function, we have 3 skills that we need to know. Number 1 is to find the equation of composite function, which is the easiest bit. Okay, so this one is the easiest. Basically, if we want to find f with g, we need to know it's basically like f gx. Okay, so basically what does that mean is that I'm going to use gx to replace the f in the f function. Okay, so we know the f function is 2x minus 1. Basically, we're just going to replace this x with the gx. Okay, so that would be 2. Okay, and then the x, I'm gonna replace the x with gx, which is 3x squared. And then I should have a bracket here, but it doesn't matter for now. Okay, so that is the composite function equation. Does it make sense? And then of course we're gonna simplify it. So therefore that would be 6x squared minus 1. Good? Alright, can I get Xander to do the second one with me together? So G with F, that will be G Fx. Okay, Xander, can you please tell me how to find the equation of this composite function?
3x squared. Gx is 3x squared.
Gx is this one, Fx is that one.
Alright, 3.
3?
3 brackets 2x minus 1.
Yeah.
Squared.
Very good. Okay, that's all right. But it will be good for us to simplify, so we can extend it. So 4x squared minus 4x plus 1. Okay, therefore 12x squared minus 12x plus 3. Okay, so that is the composite function equation. Right, raise your hand if it makes sense to you. I don't think skill 1 is too hard, okay? Everyone should be able to get it because we learned that in year 11 already. Okay, then let's move on to skill 2. You can see that in your booklet as well. We will do the now you try question after I go through the 3 examples. Okay, skill 2, we are going to find the domain. We're going to find the domain and the range of a composite function. So I already put this down on the booklet, so you can, I already took the notes for you. So basically, the domain of a composite function equal to the domain of the inner function. Why is that? Because if the inner function is not defined, all right, then the whole function will not be defined. Does it make sense? Therefore, in order for the whole composite function to be defined, you need to make sure the inner function is defined. So therefore, the domain of the composite function is the domain of the inner function. Okay? And how about the range? The range of the composite function is the range of the new composite function. So just now we find out the 2 composite function equation, right? And then we look at them and just use our normal skill to do the range. Does it make sense? But you need to pay attention to the domain. Okay, if the domain is restricted already, then the range would be restricted as well. Yes.
Would you say normal skills is subbing in the domain to find the range as well?
You can't just sub. So when can we sub the domain into the range? When it's one-to-one function, you can sub the domain into range to find. But if it's not one-to-one, you need to sketch it. If we want to find the range, the best way is to sketch it.
Okay.
If it's one-to-one function, then you can sub in because it's either increasing or decreasing. In that case, you can sub the x value into y to find the range. Okay, so let's have a look at the examples here. So I want to find f with g, which means is f gx. Okay. I want to find this one. I want to find the domain and range. So first of all, the domain equal to the domain of the composite function equal to the domain of inner function. Mira, which one is the inner function, gx or fx? Gx. So it already tells you the domain for gx, right? So what is the domain for gx? Read the question. That's h. Hold on a second.
Is H supposed
Oh
to
yeah. It should be f.
Positive real numbers?
Yeah, it should be f here. Sorry about that.
All positive real numbers.
Positive real number. Okay, so this is g, right? Okay, so which means the domain for inner function is positive real number, which means the domain for the whole composite function should be positive real number. Make sense?
Yep.
Okay, how do I find the range of the composite function? It will be the range of new composite function, right? So which means I'm gonna find out the equation. So that would be so it would be gx is this one, hx is that one, so that would be 3x plus 2 squared. Does it make sense? Okay, and for this one, what is the range for it? What kind of shape is it? What kind of shape is it? Is it hyperbola, truncus, square root, cubit, parabola? It's a truncus, right?
Yeah.
So basically, I don't have any translation on y-axis. I only have some translation on x-axis. So basically, we know this one is, the range is from 0 to infinity. Does that make sense? So the range would be from 0 to infinity. Okay? 0 to infinity. Oh, it's still all the positive. Yeah. Same thing. Does it make sense?
Yep.
Okay, the other one is the same, so you can have a go later. Alright, then let's talk about the last skill. Okay, this one is the hardest one. Not all the composite function is defined. Okay, some composite function is not defined. How do we determine whether a composite function is defined or not? Whether we have a composite function. Okay, so basically a composite function is defined only when the range of the inner function is a subset of the domain of outer function. What does that mean? Why is that? So let's imagine, okay, we have f gx, okay, and then let's imagine the range of gx. Let's say it's from -2 to infinity. Let's say that, okay? Just imagine, okay? So there's no question, not this question, okay? And then let's say the domain of fx equal to 0 to infinity, okay? Let's imagine this is the case. Not that question, let's just imagine this is the case. Then, which means gx, it can be -1. Does it make sense? Because -1 is in this range. So gx can be -1. And then you sub -1 into here, right? Because gx can be -1, which means this can be -1, right? And then you put -1 here, because we know that f, the domain for f, it's only from 0 to infinity, right? What does that mean? It means if I put -1 here, it should be undefined. Does it make sense? So what does that mean? It means that if you want a composite function to be defined, okay, then the range of the inner function must be a subset of the domain of outer function, okay? And some people might wonder what is a subset. If you don't know what's a subset, basically you can just say, oh, this interval, if A is a subset, if something is a subset of B, it means that B includes everything in A. Okay? Does it make sense?
Yeah.
Subset. Yeah?
Yeah.
Yes.
So range of inner function function must fit into the domain of Apple.
Yes, exactly. All right, so that's how we test whether or not the composite function is defined. Okay. Then let's have a go on the questions. So now let's try to see f with g whether it's defined or not. So f gx. Okay, whether it's defined or not. Basically, we want to know the range of gx. Yeah. What's the range of gx?
The range is R.
Gx is here, the range is R. Very good. And then we're going to look at the domain of fx. What's the domain of fx? All real number, okay? So whether this one is a subset of this one.
Yeah.
It is, right? It's when they equal, it's the largest subset. Okay? So it's a subset because this set, like this interval, includes all the elements in this interval. So it's a subset of that. So which means it's defined. Make sense? Okay, let's try the other one. The other way around. Gfx. Okay. So first of all, I'm gonna find the range of which guy? Fx. The range of fx. What's the range of fx?
X is greater than 0.
Hold on a second. This one.
I thought that was the range.
Yeah, okay, we didn't look at this. Sorry, so let's redo this one.
My bad.
So this one is all the real number.
Even if it was X,
Oh, no, it's
It's union
zero, it's still all real.
0. Okay.
it's
So
not
no. So this one is not a subset. Yeah. So this is undefined. Yeah. Does it make sense? We didn't look at that. We thought it's that one. Okay. It's here. Okay. Does it make sense? Okay. And then let's look at the next one. What is the range of fx?
It's fine.
So it go like this, right? So what's the range?
0. No, R plus. Sorry.
It's due from 0 to
R
infinity.
plus including 0.
Yeah. 0 from infinity because this is the lowest point and that's the highest point to all the way to positive infinity. Okay, and then we're going to look at the domain of gx. Okay, the domain of gx, where's gx? Here. What's the domain of it? It tells you it's all the real number, right? So now we're going to look at whether this one is a subset of this one. Is it?
Yes.
It is a subset, right? Because this guy includes all the elements in the first guy. So it's defined. Does it make sense? So that's how we determine whether it's defined or not. Okay? Alright. Okay, if it's defined, then you can say it's domain and root, okay? So we already know how to find the domain. And what does it mean by root? Root means equation, okay? So the same thing. That's what we did just now.
So for the sack, right? For the sack, right? It's this stuff and translation. Not translation.
It's everything.
Not
It's
translation.
for the sack.
Differentiation.
For the sack, functions, inverse function, composite function, basically everything in booklet.
Everything in the booklet.
Yeah, the skews, but the sack will be very different from the normal exam. It's not like one question, second question, third question. It's one application question that go through 4 hours. So we're analyzing one question, but it lasts for 4
Will it
hours.
practice sack or not?
It's harder than practice sack, but it includes all the skills in practice sacks. So practice sacks, you need to know all the CAS skills and everything, and you need to apply that in the actual sack. Yes.
You maybe make like a list before the holidays or like the major things.
Yeah. I will do that.
So, do you have another copy of the practice set? Because I didn't get it.
It's not a copy; it's a soft copy of Teams.
Oh, it's on Teams?
Yes.
Oh, okay.
All right. Last example, and then you can apply it on your own. Oops. And this is the last thing. We'll be teaching this term. okay, before our SAC. So next week, we have the last week, okay? Next week, we will be going through the practice SAC and going through and doing some revision, okay? And let you know what you're gonna prepare for the SAC during the holiday. All right, last example. So, state why G with F is not defined. We already know how to do it, right? Can I get someone here to teach us? Jude looks really keen.
Yeah. Okay.
Come up here and teach us. If you don't mind being recorded, you're
This is criminal.
go.
Let's go to.
You're gonna teach us, not just do the solutions.
Okay.
Maybe we can question you, teacher.
Okay. So it's the first one. It has to be, since it's GF, has to be the range of F is a subset of the domain of G. Yeah. So the range of F is. Write down. Don't do anything. I don't know.
Do GF and everything
The-
Oh, whoops.
Is that bananas?
Yeah, that is the range of
That is the
FX.
range of F.
They write down so that some people are visual learners, they want to see that. Okay.
Okay, and then you need the GX domain. Which is looks
It's like C.
Yep.
and since you have the -1 there,
Yeah, so it's not a subset.
it's not a subset.
Yeah. So you need to write in words
Oh,
because this is not a subset. Okay.
No, that's domain.
All right. Very good. You still have the. Okay. Thank you, Jude. All right. For the note. Good job. For the notation here, though. Okay. For notation here, though, the best way is to write. This is called a subset. Okay. This is called a subset because it's not a subset. We just say not a subset. That is the more
is it a
appropriate.
C shape?
Yeah, like a C shape, and it's more like like this. I don't know how to describe it.
Basically.
Okay, so this
Normal
is not a
C.
subset. Yeah, sort of like that. A shorter C. Okay. Then how about B? If we want to find, because it's not a subset, it's because it's not a subset, which means it's undefined. But Clyde really wants to find the equation of the composite function. All right, Clyde really want to do that. So can we actually do that? We can still do it, even though it's undefined. Because when we say it's undefined, it's in a certain interval is undefined. But for the majority of the interval, it's defined. So if we restrict the domain, all right, and only focus on the interval where it's okay to be defined, then we just look at that bit. So that's called restriction of the domain. How can we do it though? So the best way is, because this is not a subset of it, if I make this one 0 to infinity, then they equal, right? If I can restrict this domain to here, so this is from -1 to infinity, right? If I can reduce the domain from 0 to infinity, then this one actually exactly equal to this one. So it will be defined, it will be a subset, right? So that's how I restrict it. But this is not a domain though, this is a range. So first of all, I restrict the range, okay? So I restrict the range for f.
X squared.
So f is this one, right?
Yeah.
The range originally is from -1 to infinity, but now I want it to be only
0.
from
0 to infinity.
0 to infinity, right?
Yeah.
Which means it's bigger or equal than 0. Does it make sense? So this means the range.
Yeah.
So I just made this bigger and equal to range. And so for x, and that's the restricted domain. Yeah? I restricted the range first,
So we'll get.
and then we restricted the domain.
How would you write it though? So would you just say?
Okay, I'm gonna write everything for you. So like
Oh, let me put some lines.
Okay, in order, you can just say, in order for the range of fx be a subset of the domain of gx, so the range of fs should be 0 to infinity. Yeah? Therefore, x minus 1, x squared minus 1 needs to be bigger equal than 0. And then we can try to solve for that. How do we solve for this? How do we solve inequality like this? When we're solving for inequality, the best way is sketching. Sketching. How do we sketch it? So can we sketch this one? It's a parabola, translate 1 unit down. Yeah? And now we're talking about the y value is bigger or equal than 0, so which means this part is gone. Does it make sense? Yeah. So the x value would be from negative infinity to here would be negative 1 and 1, right? So the x-intercept, we can just make it equal to 0, so for x-intercept, so that is the x-intercept, right? So from negative infinity to negative 1, included because there's an equal 0 here, union 1 to positive infinity. So that is the restricted domain. Does it make sense?
Yeah.
Okay, and then now we find that, and then we can do the same thing to find the equation of the composite function. As long as it's defined. You can't find the composite function when it's not defined. Now it's defined because you restricted the domain, and then you can find the composite function. All right. And there's another notation though. But if you write this 100% correct, you can also write all the real number except for negative 1 to 1. Yeah. Either way. Okay, I'm gonna leave these notes here, and then for the rest of the lesson, I want you to work through the booklet. All right, do all the questions, including the now you try questions on the booklet. And if you have questions, ask me. All right, next week, like I said, we're gonna do revision for our SAC. And be reminded when we come back after the holiday, week 1, week 2, you have 4 lessons during the SAC. It lasts for 4 hours. Okay. One more reminder for the girls there, because you obviously need to pay attention just now. The SAC will be very different from our normal exam. Will be very different from the question that we've been practicing. Okay, the SAC will be application SAC. It's only one question. It extends to like almost 40 questions, 40 sub-questions under around one topic, okay, around one background. So it requires very high literacy skill.